This is AP Calculus AB Worksheet 1-4, Continuity at a Point. For the first front side, 1 through 10, determine where any points where the function is not continuous. So we just need x values here. So for number 1, we can say at x is equal to 1 because this point here at 1 has a hole. You don't have to do this, but I'm going to do it on mine where I identify what type of discontinuity I have. So I'm going to say that one is a hole. And then on number 2, we can see that there's this spot right here where I have to pick up my pencil, come over here, pick up the pencil again, and then come back to the rest of this. So this is at x is equal to -2. I call that one a gap, but some people like to call that a jump discontinuity. In number 3, again, every year I kind of debate whether I should include an endpoint discontinuity because you do have to pick up your pencil and then there's nothing else going on. So I'm going to include it in this worksheet, of course. So x equals to -4. It's an end discontinuity. And in number 4, we have this vertical asymptote happening here. So if I do a dashed line, I never get to that point. I have to pick up my pencil to get from here to here. Therefore, that is at x is, I want to change that to normal handwriting. At x is equal to -1, and that is a vertical asymptote type of discontinuity. All right, let's look at number 5. And again, if I put a point at the very end, I usually assume that's an end discontinuity. If there's a line that goes on forever and ever, let's see if I can find an example. So this line goes forever and ever. I should be putting arrows on that, but it's kind of hard to do that in GeoGebra when I'm designing these graphs, so I just leave them off. You assume that it goes on forever and ever unless there is a point at the very end. All right, so I'm going to circle all the ones that I have to talk about. This is an end discontinuity. We have a jump discontinuity, or gap discontinuity, another gap discontinuity, another gap discontinuity, and then an end discontinuity. So it's literally almost every single point except for x equals to 1. So you can say x is equal to 0, x is equal to 2, x is equal to 3, x is equal to 4, and x is equal to 5. Like literally all of these. This one is an end discontinuity. This one is another end discontinuity. And then we have a bunch of gaps. A gap, gap, and a gap. In number 6, let's circle them all. We have an end, a gap. This sharp corner is okay because I didn't pick up my pencil. I have a hole here, so I'll circle that one. We have a hole, we have a gap, we have another hole, even though it's like a removed hole, like it fell out of the function. And then we have another end. So each of these is a discontinuity that I like to identify. So x is equal to -3, x is equal to -1, x is equal to 1, x is equal to 2, x is equal to 4, and x is equal to 5. Okay, let's identify the types here. So we have ends on each side. And then the first two are gap discontinuities. Gap discontinuity, x equals to another gap discontinuity, and finally, oh wait, one was not a gap. I see that was a hole. It's my bad. One should have been a hole. And 4 is also a hole. I thought to myself, there can't be that many gaps in a row. All right, number 7, what do we have? Let's circle them. It looks like I have a hole, a gap, and a hole, and there are no ends on this one. So this is going to be x is equal to 3, x is equal to 7, and x is equal to 10. So we have a hole, we have a gap, and we have another hole. In number 8, I have a hole here, I have a gap here, and a hole here. So let's go ahead and identify those. X is equal to 1, x is equal to 5, and x is equal to 7 with a hole, with a gap, and with another hole. All right, number 9, we have an end discontinuity, we have a hole, we have a gap, we have another gap, and we have an end. Again, this point doesn't mean anything, it just means there's a sharp corner there. That's okay to have. You didn't have to pick up your pencil, right? So x is equal to -3, x is equal to -2, x is equal to -1, x is equal to 2, and x is equal to 5. I like doing the ends first. Another end. And then we have a hole for -2. We have a gap for -1, we have a gap for x equal to 2. And number 10, we have these vertical asymptotes, which I will put on my, so this is a vertical asymptote, this is a vertical asymptote, and we can now say x is equal to -1 and x is equal to 1. Both of those are vertical asymptotes. Excellent. Now for the slightly harder problems, the backside. For the first 5 problems, I'm trying to determine whether or not the function is continuous by testing the suspect point. Again, this 3 is the suspect point, or this 0 is the suspect point. And the general formula for all of these is you set the left piece equal to the right piece equal to the height. And very often the height will be the same as either the left or the right piece. It's wherever that equal to sign is. So in this case, there's an equal to sign in this right piece. So the right and the height are the same equation. It doesn't make sense to write it twice, so I'm just gonna kind of scribble that one out. I really am setting the left equal to the right. So I'm gonna set 5x plus 7 equal to 7x plus 1, and making sure all of these match up. Again, why did I not write an x here? Because I'm going to be plugging the suspect point in for x. So I'm going to plug in that 3, and that's going to make this 15 plus 7 is 22. The right's going to be 21 plus 1, which is 22, and therefore it is continuous because it passes the continuity test. So that is the full explanation. You guys can write just continuous. But if you want the full explanation, you say continuous because it passes the continuity test. I have a feeling I'm going to be writing that over and over, so I'm going to go ahead and grab that so I can copy it, and I can paste it later. All right, so again, you set the left equal. You should remember the formula. Left piece should be equal to the right piece, should be equal to the height. And in this case, the height and the left piece are the same thing, so I'm not going to rewrite the height because those are the same. I'm just going to do left is equal to right. So this is going to be x cubed is equal to x. And plug in the suspect point. Suspect point is 0 to each of these x values. So when I do that, it's 0 and 0, and 0 therefore is equal to 0. So again, it is continuous because it passes the continuity test. So I can just paste that again. In number 13, again, we're going to set up the formula. It's funny to write this over and over when I have 3 pieces for the formula. There's only 2 pieces here, so Mr. Snell, you don't need to write all 3 of them. I'm practicing, and you should practice as well so you remember the formula. So in this case, the height and the right piece are the same thing, so I don't have to write the height. And I can say this is x squared is equal to 6x minus 9. Plug in our suspect point of 3. 3 squared on the left is going to give us 9. This is going to be 18 minus 9. 18 minus 9 is 9. So yet again, it is continuous because it passes the continuity test. And in number 14, maybe we'll find one that's not continuous. So this one is an interesting problem. Basically, there's at one point, at x equals 2, we know a height. Everywhere else, this is most of the graph is this equation. Everywhere where not 2 is basically everything. It's almost, it is an infinite number of points. We are normally that function. Again, if I try to plug 2 into this, you'll see I get a 4 on the top and a 2 on the bottom, and this will be 0 over 0. It's the indeterminate form, so you have to be careful about how you plug this one in. And let me do some legwork before I write down my formula. I know that x squared minus 4 all over x minus 2 is the same thing as a difference of squares on the top. It's a square and a square with a difference, a subtraction symbol, right? So it's going to be x minus 2 and x plus 2. It's a conjugate pair all over x minus 2. This is one of those factor canceled plug-in sort of scenarios that you have to be aware of. So when I actually do try to set up the formula where I say left is equal to right is equal to height, I know that I need to, well, I guess the left, and this is left and this is right. So these two are the same in this case, and then this is the actual height of the point. So in this case, I can say that the height is 2, or sorry, the height is 1. I don't know what I'm thinking. The height is 1, and the left and the right are the same thing, and it is simply x plus 2 with a hole at the value of 2. That's why we can't actually plug 2 in. So I can really say it's basically x plus 2. I don't want to do x. I'm going to say x plus 2, and that x in this case is a suspect point of 2. So in this case, I get 4 is equal to 1, and this one is not continuous. So if I were to draw a picture of what's going on here, everywhere else, I'm some sort of function like this. So maybe I don't know, it would be, if I'm trying to guess what it would look like, it's going to look something like this, where I can't plug into, maybe it's going to be some sort of line. Is it going to be some sort of line, a hole in some sort of line, and then a value right here? That would be my guess as to what's going on. It's some sort of line because x squared divided by x is kind of like x, and this point is a value of 1 when it should have been a height of 4, so it removed the point. That's my guess, but this one is not continuous. So I can still paste this. I can say it's not continuous because it fails the continuity test. Perfect. All right. And this is a case where we need to write all three of them, right? So we can say left is equal to right is equal to height. Okay, so the left is x plus 7. So there's my x plus 7. My right is 3x plus 3. And my height is 9. All three of these should be the same thing. If I plug in my suspect point of 2, I see I get 9, which is equal to 3 times 2 is 6. 6 plus 3 is 9 is equal to 9. All three of those had to match, and they did indeed match, so I can say it's continuous because it passed the continuity test. All right, number 16 and 17 are a bit trickier, but this is the assumption. It says, okay, we need to find a value of k so that this thing is continuous. So assume, yes, it passes the continuity test. If it passes the continuity test, I know that these things have to be equal to each other. I know that this piece and this piece, I can set them equal to each other and plug in the suspect point. And that's exactly what I'm going to do. I start with the continuity test, assuming it's true. I'm going to say that 3x squared minus 11x minus 4 is equal to the other piece. It's equal to kx squared minus 2x minus 1. And then I can plug in the suspect point of 4 into all of these x values. So this assumes that it passed the continuity test, and I just solve for k now. So here we go. 4 squared is 16. 16 times 3 is 48. Minus 44 minus 4. Wait a sec. 48 minus 4 is 44, and 44 minus 44 is 0. This entire side is going to be 0. All right, 4 squared is 16, so it's 16k minus 8 minus 1, which is 16k minus 9. Let's add 9 to both sides, so we get 9 is equal to 16k. And then finally divide the 16 on both sides, and I get k is equal to 9 divided by that 16 that I just divided by. So that's the value that will make it continuous. If you don't have this value, then it will be discontinuous, and these two sides won't match up to the same height. So I should probably box my work so that the AP graders can see the answer real quick. And again, it's the same type of question. You assume this one is continuous, and you set all three of these pieces equal to each other. And that's the long way. The short way is saying, hey, I mean, just these two pieces need to be the same because you're assuming that piece is good to go. This piece and this piece should be the same if I plug in -3. And just to verify it to you, -3 times -6. A negative times a negative is a positive, and 3 times 6 is 18. 18 minus 12 is still 6, so it's kind of pointless to do all that extra work. I'm just going to set these two pieces equal to each other. So I'm going to say k squared minus 5k is equal to 6. You can start just right there and ignore that piece because you know it's continuous. Therefore, these two pieces have to be the same. Might as well make it easier for ourselves. All right, so from here, how do I solve this? Well, it's a quadratic, and I need to get all of my terms on the left-hand side unless I'm going to try to complete the square or something. So I have k squared minus 5k minus 6, because I moved it to the other side, is equal to 0. And then from here, you need to do a ninja star. You need to do some sort of factorization. So the way that I factor is k minus 6 and k plus 1. I'm doing the ninja stars in my head. And if I do the zero product property, I can say k could be equal to a positive 6 or k could be equal to a negative 1. Those are the two values of k that could work. Any other values would not work. All right, and that concludes our worksheet 1-4 for AP Calculus AB. There's the back. There's the front. Thanks for watching.